let's have Henri from Streamr introducing Monoplasma.
Hey, I'm Henri. I head up the Streamr project, but today I'm here to introduce you to something called Monoplasma. So Monoplasma is a new special purpose off-chain scaling solution for one-to-many payments. Now, we built Monoplasma because we needed it, but it's reusable, so we wanted to spin it off as a separate little contribution to the Ethereum scaling space. I hope all the biddlers gathered here today will find it useful. These are some of the things you might want to use Monoplasma for. Revenue sharing, like imagine a decentralized Airbnb with tokenized apartment ownership, where an apartment might have thousands of owners. Now, when a guest pays a fee for staying, that revenue needs to be split among all the owners of the apartment, right? Other similar use cases include distributing dividends for security tokens, doing frequent airdrops, paying out staking rewards, loyalty reward schemes, even pension payments, and so on. Basically, anything where you repeatedly fan out value to a dynamic set of accounts and want self-service withdrawals. So this talk is only 15 minutes long. So I'm going to turbocharge through why we needed Monoplasma for Streamr, and then talk about what it does and what it doesn't do, and finally show a live demo. So let's get started. To understand our use case for Monoplasma, I'm going to quickly explain the basics of Streamr. So the Streamr network is a pub-sub messaging network for real-time machine data, such as data from IoT sensors, smart cities, connected cars, your crypto market data, and so on. So it's not a blockchain, but a companion network for one, such as Ethereum. The network delivers messages between data publishers and data subscribers in a robust, decentralized, scalable way. And there's some nice cryptographic things going on, such as messages can be signed and sequences of messages can be made tamper-proof, and so on. So this is the base layer. Now, on top of that, we have a marketplace dApp, which connects to the Streamr network and to Ethereum and allows the data producers to sell access to the data streams that they're producing. So the reason why we needed Monoplasma has to do with the marketplace. So let's drill down into that. Bear with me. On the marketplace, we're working on a new feature called community products. Essentially, we want to enable large groups of data producers, such as end users owning some connected gadget like a Fitbit or a Tesla, to pool data into a collective data product. Now, pooling the data is not the problem. The problem is when someone buys that product, and that revenue needs to be split between all those data producers. Now, if there's just a handful of data producers, such as in this picture, this can be easily done on-chain. I mean, splitting a payment 5 ways on-chain, easy as pie. But if there's, say, 100 or a few hundred, your transaction grows and starts to approach the block size limit, making it impossible to do this kind of thing on-chain. And in our use case, there can be hundreds of thousands or even millions of data producers. So distributing payments to this kind of huge crowds is nowhere near possible to do on-chain. So we built Monoplasma. Our requirements were these. So we needed to distribute these individual lump sum payments among a large group of recipients, a bit like doing an airdrop every time new revenue enters the system. The recipients must be able to accumulate value for as long as they want and withdraw when they want by doing a transaction on-chain. The recipients must be able to join the pool without doing a transaction or placing a stake. Now, this is different from many other payment channel solutions out there, and in fact, it's crucial for us because the users are mainstream users, and we can't have obstacles for joining, such as having to buy ETH on day one. And finally, the system should be trustless and transparent. So we didn't really find an existing solution that would fulfill these requirements, so we rolled our own. We were inspired by the different Plasma variants and payment channel stuff, but basically we threw out everything that we didn't need in order to find the simplest possible mechanism that does what we want, and only that, while still maintaining good security properties and trustlessness. We don't have time to go through all the little differences and similarities between Monoplasma and other solutions in the same family, so I'm going to focus on the main difference, which is this. So we sacrificed generality in favor of special purpose, right? This is not a generic payment solution where everyone can arbitrarily transact with each other. No, this system is unidirectional. That means that there are no transfers between accounts on the side channel. In other words, tokens cannot be spent on the side channel. Now, why is this good? If tokens can't be spent there, there's no double spending problem, which simplifies things immensely. Since there's no spending there, balances on the sidechain are your cumulative lifetime earnings. The account balances can only increase monotonically, hence the name Monoplasma. So what about withdrawals then? Withdrawals are tracked on-chain instead of off-chain. The off-chain system records only your lifetime credits, your positive balance, and the smart contract keeps track of your lifetime debits, your negative balance. So your net balance at any time is obviously the difference. And to withdraw, all you need to do is to prove the positive component to the smart contract as it already knows the negative one. You do this by providing a Merkle proof, similar to other Plasma-like solutions out there. So if we prove our earnings on the side channel are 100 tokens, and the smart contract knows that we've already withdrawn 30 of them, it will give us 70 and update its state so that it says withdrawn 100. Now, if we prove again 100, and it knows we'll already withdrawn 100, it obviously won't give us any further tokens. So I hope that part is pretty clear. Let's cover some other aspects of Monoplasma. There's an operator-validator model. The operator controls the off-chain state, and in Monoplasma, he's actually the only party who can cheat. And the job of the validators is to make sure that he doesn't. Both the operator and the validators maintain the off-chain state in a Merkle tree, and the operator periodically publishes the root hash to the on-chain smart contract to enable withdrawals from that state. This is all familiar from other Plasma variants. One difference, however, is that there's no challenge period / exit game because there's no double spending. Instead, there's a simpler, non-interactive freeze period that allows time for the validators to exit people from the last honest block in case the operator is caught cheating. So the earned funds do become available with a few days of latency, which is fine for many use cases, including ours. Monoplasma lives in the Streamr GitHub at streamr-dev/monoplasma, and it ships with a revenue sharing demo, which showcases the functionalities of the framework. So enough talk. Let's see how it all works. Time for a live demo. Let me just plug this in here. Awesome. Can you guys still hear me? Yeah, I'm going to mirror my display. Woo. All right, so here in my terminal, I have Ganache running, and I have the demo backend running, which houses the operator. On another tab, I have a validator running. And in my browser here, I have the demo UI. So this is basically like a control panel. You can inspect the state of an individual user account on the side channel. You can see the overall statistics of the revenue pool. You can see the blocks published by the operator. You can add revenue with your MetaMask, and you can add users to the revenue sharing pool. So in my MetaMask, I have two user accounts configured. I have Alice and Bob. And we're going to start with Bob. I'm just going to copy-paste Bob's address to this box here to add Bob into the revenue sharing pool. So we can see that the member count has gone up to 1. Now, that's not a very interesting revenue sharing use case yet, so let's add some more addresses. I happen to have here 99,999 addresses, which I'm also going to add to the revenue pool to show some scale here. And here we go. Add users. Awesome. Now we can see we have 100,000 members in the revenue pool, but no revenue just yet. Now, that's where Alice comes in. Because Alice is rich. She has 1 million unicorn tokens on her account, in her MetaMask. Awesome. So let's send some of them to the Monoplasma smart contract. So I'm going to send, this is the wrong input field, over here, 100,000 unicorn tokens to the Monoplasma smart contract like this. And we should see some numbers appearing here. So the operator published a block that is seen here. It's still in the freeze period, so those earnings are frozen. They cannot be withdrawn just yet. In this demo, the freeze period is only 20 seconds instead of, say, 2 days, just to make this demo go a little bit faster, right? Okay, and now these earnings are unlocked. We can see that from here. Let's do that again to show how the value in the side channel accumulates over multiple revenue-adding transactions that we do here. Let's make a few so that the total we've sent into the smart contract is 1 million tokens. So here we can see there's now 1 million tokens in the revenue pool, hopefully distributed to these 100,000 members equally, which is the logic in this demo. Now, if you remember, Bob is one of those recipients in the revenue sharing pool. So I'm going to go back to Bob and copy his address. And we can see in MetaMask here that Bob has 0 unicorn tokens in his wallet. However, he might have some in the side channel. So let's inspect his address, and we can see that, yes, he indeed has 10 tokens, which he's earned in the side channel. So the way for him now to get those tokens out from the side channel onto his wallet is to provide the Merkle proof. And we can do just that by clicking this withdraw button over here, which bundles that proof into a transaction, sends it to the Monoplasma smart contract, and now, watch this. Watch this number. Boom! Here we go. So the earnings available went from 10 to 0, and total withdrawn went from 0 to 10. Now, that may not look like much, but actually something very cool just happened here. If we go to look at Bob's account, we can see that 10 unicorn tokens have indeed been withdrawn from the side channel onto Bob's account. And Bob was just one of those 100,000, so anyone else in the pool could do the same when they want or keep accumulating more. All right, awesome. Now there's one more thing I could show you because it's fun. We still have a little bit of time maybe. So there's this one big red button that says steal all tokens. And it looks like you shouldn't be pushing that. So this is a button where we can trigger the operator to commit fraud and try to steal all the tokens for himself. So let's see what happens when I push that button. The operator will publish a fraudulent block, which is seen over here. It has only one member in it. So the operator is now waiting for the freeze period to end so that they can take all those tokens for themselves. But we had the validator running over here. So now the validator has detected that, whoa, that something fishy is going on, and the validator has attempted to exit the account that he was watching. In this demo, there's just 5. But that leads to a situation where the operator can no longer steal those tokens because the balances have changed. The validator has kind of prevented that from happening. So we can see here on the MetaMask that there's a red box that will say that this transaction will not go through. So the validator saved the world this time. Awesome. So that's pretty much a quick review of that. So if you think this might be useful for whatever you're building, clone the repo, play around with this demo, reach out to us if you want to chat about it, and so on. Good luck, and thank you very much. And we'll be here if you want to chat about Monoplasma or Streamr. Just come talk to us. Awesome. Thank you. I don't know if there's time for questions or not. There is? 2 questions. Yeah. Yeah, here's the repo. Any questions? All clear, clear as day. Yep.
So on the side channel, you're keeping track of how much of the unicorn tokens Bob has. So who is storing that?
So that the operator is storing that and the validation. Oh. Awesome. So that information is governed by the operator, but the validators will also kind of replicate that information to see if it's correct or not. So yeah, the operator is control of the state, but if there's anything weird happening there, it will be caught by the validators.
But there's no mining for the validators. How do they know?
There's no mining. In this framework, this is kind of unopinionated. So you could add, for example, for the operator, the possibility to place a stake, or for the validators to earn something by validating. Usually, in our use case, the operator will have an incentive to run this system due to business reasons. But in the general framework, anything can be added, of course. This just specifies the kind of interfaces between the components and the mechanism of withdrawal in there. And Juuso over there can also chat about the deeper technical stuff related to this. So he'll be an awesome resource. Yeah.
So yeah, I mean, this is kind of like the simplest, like the kind of MVP demo kind of thing. But obviously, all this kind of management that's involved could be could be turned into some sort of DAO or you know, there's a lot of governance solutions out there, and of course this didn't include any of them. So definitely like a future development.
Awesome. Thanks, guys. See you later.
musicians?
I don't know. I might just wander, wander right off the stage.
Do you want to take this out then?
Yeah,
Where's the other one? Okay, so up next we have Josh, who's a head designer at DDX and Hydra Protocol, and he will chat about debunking the myths of design. DApp design. Right. That one. So, Josh, over to you.
Hey, what's up, everybody? Obviously, today I'm here to talk about debunking DApp design myths. So there seems to be this notion that designs or dApps can be poorly designed and have lackluster user experiences because we're early on in this technology. We're still in the quote-unquote infra stage. And so I want to today, in no uncertain terms, basically debunk that and call bullshit. There's no reason to have poorly designed dApps. But before I can kind of move on and hopefully validate that, I'll give you a little bit of a background about myself. So I used to be a pro skateboarder, believe it or not. Some of you might say, cool, well, what does that have to do with anything? And it just happens to be that when you fly off buildings and you essentially make a living flying down handrails and balancing on an inch of metal while trying not to over or underbalance by a pound, avoiding death and dismemberment, you get pretty good at either managing risk or ignoring risk. And so those tend to be qualities that entrepreneurs have. And so when I essentially retired at 24, I went on to then start a bunch of different companies. And I built a bunch of different companies across various different spaces. I tried to build a personal operating system. I built a military contracting company as well as a bioinformatics company. And so one of the themes that kept popping up is I seemed to keep working on these very complex technologies, and I had to find ways to simplify them into intuitive user interfaces, which just happened to be one of the pain points for decentralized applications. So how I got started in this space was I would try to use different products. When I ran into different friction points, I'd basically try to fix those products, and then I'd send them to the company completely unsolicited and see what they would say. And so eventually I ended up getting hired by Radar Relay. I ended up staying there for a little bit, and then I moved on to then become the head designer at DDX and Hydra Protocol, where I'm at now. One of the interesting things about DDX and Hydra Protocol is I get to work on products both at the protocol layer and at the application layer. So if you don't know, DDX is one of the top decentralized exchanges, and then Hydra Protocol is essentially a protocol for performance-based decentralized exchanges. And so by virtue of this very symbiotic relationship where we have an application and then we have a protocol and they each feed into each other, I've really had the honor of being able to work across a number of different products. So in the last 12 months, I have designed browser-based apps, native iOS and Android decentralized exchanges, responsive, fully featured decentralized exchanges, dashboards, iframe, embeddable, instant trading widgets, developer documentation, onboarding flows, custom wallets, and now something that I'm working on is a multi-chain, mobile-based decentralized exchange, which is a mouthful, but easier to design than it is to explain. So when I was thinking about what I could do today, I thought I could probably teach people how to design decentralized exchanges, but I didn't feel as though everyone would find that valuable. I thought about picking some products and trying to point to good things and bad things, but I didn't feel as though that would lead or leave anyone with anything tangible. So I thought the next best solution would be to basically mock up a fake product and walk you through at least the way that I approach designing these products. Because when you're working on so many different products, you at least have to have a method to your madness or a mental model. And so that's what I want to share today. So the concept is going to basically be this. It's going to be a very small subset or a feature set of a much larger system. In this, we're going to essentially talk about letting a user transfer tokens from one address to another. And while admittedly it looks very simple, in a very quick fashion, we're going to go over error handling, form validation, handling local and global state, different types of micro interactions, different types of foreground, background, and push notifications, writing microcopy, thinking in terms of third-party wallets and how to make that experience for a user simpler, as well as different input accessories and using smart defaults. So we're going to make an assumption here that there is an underlying interface that you can't see. The user has basically clicked on a transfer button of some sort, and then a modal has basically popped up. And so when a user basically sees this, or a stakeholder or someone watching this sees this, they see this type of interface. For myself, I see this. And so this is basically my mental model whenever I come into designing any type of product. I know for a fact that I'm going to need some type of inline foreground notification. These take the shape of toast, little drop-down banner notifications. They could be push notifications. They also have different states, such as your pending, success, and warning states. But we'll talk about more of those in a little bit. I also know that we have to have an action title and some kind of descriptive microcopy that helps the user understand what they're about to do and framing their expectations. I also know that we're going to need at least 3 different forms and all of their various states. And then I also make sure that if this is a transaction where a user is having to sign something, we also have some type of wallet message in there. Then obviously we have a couple of buttons that allows a user to enter or exit in or out of a flow. So moving top to bottom, it's almost offensive that this is here, but I see products over and over again do this wrong. They don't have a title, they don't have a description, they don't frame the current action that the user is going to take. And this is an important thing to have because as you're designing responsive systems, you never know where a user is going to be using your application and where they're going to be triggering something from. For example, if this is on a mobile device and a user clicks a transfer button and this modal pops up, there's going to be enough content in this modal where it's going to obstruct the entire view behind it. So if a user doesn't know where they're at, you're going to need to tell them. So how I tend to handle this is I just take a very basic description. I just basically describe the action. I just say, you're going to transfer tokens. And then I give a description underneath that that then almost tries to describe the interface below it. And now I'll fully admit that this isn't the tightest microcopy in the world. It's not amazing. You can play with all the cadence and the tone and all that kind of stuff. But it's good enough. And I know it's good enough because a user can read this in plain English, and in absence of the rest of the interface, they know what they need to do. They need to transfer a token by adding an amount, a token, and a recipient address. So once you've handled your microcopy correctly, then you can play with all the fancy stuff like your font weights, heights and colors, and all your vertical rhythms and all that kind of stuff. But that's not too important right now. Next, when you're handling tokens, it's a best practice to have both the ticker name and the project name. There is no way just to own a ticker outright. And so I know this for a fact that there will be clashing project names and tickers. We have this at Hydra, where our token is called Hot. And then there's also a project called Hollow Token, who has a token called Hot. And then there's also another project called Hydra Protocol as well. And so in the interface, you just need to basically handle this and make these exceptions. And some people might say, well, I just like to be as concise as possible. I just want to have the ticker in here. I don't need the project name. I'm manually reviewing my tokens. But let's say that this token or this ticker is maybe in your top 20 tokens, maybe has $1,000 worth of volume. And then let's say that I like this ticker because it has a great name. I would just pay you some money to drop this ticker and drop this token and then list my token. And you're going to do that because I pay you enough money to do that. And then if you're not handling your project names, you're going to have to chase these exceptions around your product and basically making these manual flags trying to basically correct or help users understand that this isn't the old token, this is a new one. So just use tickers and project names. When you're handling an amount, there's a few things that I like to do here. First, I always like to put a max amount in or the max amount that a user has in the amount field as an assistive label. And the reason that I like to do that is because I don't want a user to abandon a flow. I don't want a user to have to exit out of this, go to their wallet, see their balance, then come back and enter into this modal all over again. I'm a strong believer that you just keep a user in a flow, and within that flow, you give them everything they need to complete an action. Another thing that I see projects do is not use placeholders. This is kind of form design 101. So always put a placeholder in there that is descriptive. Another thing that I like to do is give users the ability to have some kind of smart defaults. And so in here, for the most part, what a user is going to be doing is sending a max amount of their tokens, basically sending them all out at once. But I also like to give users the ability to send a smaller percentage of their tokens. And when I do this, I like to have both a percentage as well as the actual token quantity itself. And I find that this kind of assistive thing, whether you implement it or not, at least says and communicates to a user that you find this valuable, that you find them valuable, and that you're trying to make their lives easier, regardless of whether they're going to use it or not. Next, addresses can be a little bit funky to handle. There's essentially two ways to handle an address. One of them is long addresses, and the other one is short addresses. And you can do something in between. So I think that this is basically optical gibberish. It doesn't make any sense. It's difficult to read, and most users are going to look at that, and it's just going to look like a blur of characters. And so a pattern that is starting to emerge is these kind of short, truncated addresses, where you basically have the first 4 and last 4 characters of a wallet, of an address, sorry. And it just makes it a lot easier for a user to be able to understand. And this is actually a pattern that's very similar to handling credit card forms, where you have the last 4 digits, and a user just has to kind of quickly verify just a small section of their addresses. Another thing that I think is really awesome is Wallet Connect. We use that in DDX, and it's just a very simple way for a user to be able to automatically scan an address and then input that address into here. Typing these things out is a pain in the ass, and most people are going to copy-paste them. QR codes or QR scanners aren't a big deal in the West right now, but if you've ever been to China, they're basically used for absolutely everything, especially if you've used something like WeChat. You'd know how valuable and how useful of a tool QR scanners are. Next, this is something that pretty much everybody does wrong, which is handling errors. I call these essentially local errors, and a local error happens on a local component. And I've seen these error messages either not be shown or be shown in kind of these little toast pop-up messages, which are just terrible. I've seen them put them at the bottom of the forms. I think it's just the best idea to basically put it on the same line as the label. If you're kind of constrained for space, you can also put that underneath the input as well. A good error message also needs at least 3 things. It needs to identify the issue. It needs to tell a user how to mitigate that issue, and then it needs to be written in plain English. So you don't want to be telling someone or giving someone some kind of like code-based error message. Just think about how you're going to communicate to a user the issues that they'll be facing on any of these inputs. The next thing that I think is also very important, and I don't think many products take into consideration, is thinking in terms of third-party integrations. And so when you're using a dApp, you're usually going to be using something like a MetaMask wallet or Ledger. But I can't count the amount of times that I've had issues with MetaMask where I've clicked on a button and then the modal hasn't popped up. And so I keep clicking the button thinking that the interface is broken, and then I see a slight incrementing on the notifications up in the browser window. And this is a relatively difficult thing to deal with, but one of the things that I personally like to do is to think about the wallet and then describe that interface and then tell a user some of the issues that they might be running into. So in this example, this is something that I would do, assuming that the user has MetaMask installed. So this, basically like this assistive message says, upon clicking submit, you'll also need to confirm within MetaMask. If a window doesn't pop up, click the MetaMask icon in your browser to complete this transaction. Again, this could be much tighter. We could do a lot of different things to make this microcopy better. But in this 2-line sentence, basically, what we've done is we've essentially identified any of the potential issues that a user might have and told them how to kind of mitigate that. And so you're going to need to do this for your MetaMask as well as your Ledger wallets and anything else that you want to integrate. Next, gas and transaction fees. There's many different ways to handle this. You could do it like this, where you have some kind of drop down that allows a user to pick between different speeds for gas. One thing that I firmly believe is that we shouldn't be showing gas limits in an interface. I think that's far too complex, and we need to figure out ways to kind of abstract that complexity away and just give a user smart defaults, basically. And so when I look at this, I say there's a few different elements. First, we have a speed, we have a time, and then we have a US value for this transaction fee. I personally think that this looks a little bit too complex, and I think this is one of the troubles when you're trying to simplify an interface, is that you can essentially, by trying to make things simpler, you actually make them more complex. There's definitely a point of diminishing returns when it comes to simplicity, and so you want to make sure that you kind of almost refactoring the design and these components as you're walking through them to lower the cognitive load on a user so it just looks completable to them. So I personally wouldn't go with something like this. I'd probably go with something a little bit like this, where instead of kind of letting a user pick the different speeds, I just say how long it's going to take and the approximate cost in microcopy, basically. I think that one of the products that really does or handles gas and transaction fees really well is Balance. They have a pretty intuitive kind of feature on their wallet where you can just, again, pick between fast, slow, and average speeds. And I try to steal that as often as I can in any kind of product that I'm using, because I think that that's a really awesome feature. Another thing that I see a lot of products not doing is handling their form validation. And so what will happen is that they won't validate the form, and then once the user clicks submit, then they'll throw an error. That's kind of not how you handle forms, right? So you should be validating each input as a user is moving through it and throwing an error message whenever a user puts some kind of invalid value in there. One of the things that I personally like to do, I think, which is the quickest win, is just to put an opacity on the label of 50% and then throw a cursor not allowed on it, just so a user knows that they cannot click on this button. There's also some other cool little micro interactions that you could do here. You could do both an on-click and an on-hover event for this submit button, so that if there's an invalid form, like a missing address, when the user hovers or clicks on the submit button, it then throws that error all over again, and the user can then just move up quickly, enter in that address, and then move forward. Once the form is valid, I just basically turn usually the label back into 100% opacity, or 0% or 100% opacity, which is a nice little subtle gesture, I think. The next thing that I think a lot of dApps need to think about is just the different states for the application, and to be mindful of how that interface needs to respond to those different states. So in this example here, the user has gone through, put in the appropriate information, they've clicked submit. Now, this user is now, in this example, up in MetaMask confirming this transaction. And so the button should go from submit and then basically communicate some type of pending state. And another thing you can do here is just disable it so a user doesn't try to submit that transaction all over again. This is also something that I'm very opinionated about. A lot of dApps or applications aren't really handling kind of inline global errors or global notifications. So a pattern that I see a lot is that a user will submit an action or a transaction to the blockchain, and then the app will show some kind of like little translucent toast message that pops up in either the top left or the top right of the screen. I personally think that it's a very poor practice, because if a user is at their computer and then they get a message on their phone, they glance over to their phone, or they go to get a drink or go to the restroom, they're going to miss that transaction. And so that interface isn't communicating to the user that something happened. And so another little mental model that I like to think of when, or like to use when I'm thinking about notifications is there needs to be 4 elements. There needs to be a trigger, there needs to be a notification type, there needs to be a place to retrieve that notification, and there needs to be a way to archive that and basically clean it from the view. So in this example, the trigger would be the user clicking submit within MetaMask. The notification would be some kind of foreground notification. It could also be a push notification. And then there would also be a secondary activity center where the user can come back in and go through their historical transactions. And then we give them the ability basically to archive those or remove those from the view. Same thing with global error states. In this example, this is not actually the best example because once that transaction would have been submitted, this modal will have presumably disappeared. But I'm just trying to kind of articulate how you could handle a successful transaction. And so a couple of things that I always like to do is basically reconfirm with microcopy that that transaction was submitted. Also give them the ability to view that in some kind of block explorer like Etherscan, and then also let them know that they can review this notification back in an activity center later on. Lastly, clear your form state. Once a user has submitted a transaction, make sure that you just deleting or removing all of the token, the amount, and the address, and whatever other information is in your within your UI. It would defeat the purpose if we go through all of this effort to make easy to use amounts, and we describe interfaces, we use really tight microcopy, and then we just leave the inputs with the data in them, because a user is just going to view that as it wasn't submitted, and they're going to click submit, and it's going to be frustrating and lackluster. So I guess the main takeaways is that things are going to change within your product, within your interface, within your business. They could be regulatory, they could be competitive threats, they could just be features being added or removed. And so you need to architect your applications in a way that are very, very flexible, which is kind of easier said than done, but at least aim for that. The next thing is that context is king. It is important that you understand how a user is using your application, not just within the application itself, but within the environment that surrounding them. For example, when I gave the example of a toast notification popping up, and then them glancing at their phone and then missing that notification. So just try to keep the context of the user in your mind as often as possible. Second to last is, this is an early space. I don't think anyone's necessarily winning at this stage. So if you see something that you like in terms of UX or UI, just either beg, borrow, or steal. I see little cool things all the time that I take because I think they're really interesting UX innovations, like balances gas fees. So I think that's cool. And at the end of the day, you just need to keep it simple. Don't try to overthink it too much, and just stick to traditional Web 2.0 best practices. Lastly, these are some of the, I guess on the left, some of the people who I think are worthy of a follow. And then on the right-hand side, some of the companies that I think are doing innovative designs and thinking about UX in the space differently. If you're an engineer, you're probably going to want to follow Beltran, who's Lyrical Polymath. He's basically trying to write the Web3 design standards, and it's someone who I personally look up to and basically take his word as law. And then there's obviously lots of cool companies like Balance and Dharma's little widget that they've just put out, and all of their products look really good, as well as Portis and Consensus Design, as well as Wallet Connect. Lastly, if you want to follow me, that's my Twitter handle. It's Josh_Rio. If you ever want to send me an email, it's just josh@ddx.io. And also give DDX and Hydra a follow, because if it wasn't for them, I wouldn't be standing here, and I wouldn't have had the opportunity to work on lots of interesting products, learn lots of cool things, and to be part of an awesome community. And I am finished.
you a question?
Sure.
Cool. Hey Josh, what would you say is like the biggest pain point in crypto in general when it comes to design? Like what's like the cardinal sin and what is the hardest thing to design around?
That's a very good question. The hardest thing. I actually think the design is the easiest thing because if you keep it simple, it's not that difficult. I think one of the hardest things is communicating to all the different stakeholders within a project what the trade-offs are. And so DDX is a very interesting project where we have both a Chinese office as well as a US office. And so Eastern and Western design philosophies are fundamentally different. And so a lot of the time I have to find ways to communicate Western design philosophies to the Eastern team and then Eastern philosophies to the Western team. Outside of that, I think that it takes a lot of courage to design simple things because you have to toss away a lot of different stuff. It's safe to be complex. It's much more riskier to build simpler products. So I'd say probably the hardest thing is taking the risk of making things simpler. Yeah, hopefully that answers your question. Yeah.
Right. About the Ethereum addresses. So what do you think of these like pictorial representations, avatar or something like that? Have you used those, and what do you think of those? Are they usable or just?
I haven't used them myself. I do see like little avatars up in MetaMask, but to me as a user, they don't necessarily mean much. It looks like a placeholder avatar, and I don't.
Like, is it like less like a fuzz than the long address of characters?
I think anything is better than a long address. I think ENS will obviously probably help with that at some stage, but I don't think that we're necessarily there yet, and it doesn't have the adoption that it needs. But I think any type of innovation, whether it's an avatar or gravatar, whether it's a short address or whether it's something else that is yet to be invented, will be beneficial.